Well, the picture's pretty bleak, gentlemen. The world's climate is changing, the mammals are taking over, and we all have the brain about the size of a walnut. Perfect for Chapter 4. So the goal is to describe changes in ecosystems resulting from seasonal variations, climate changes, and succession. Our objectives are to differentiate between weather and climate and identify the factors that affect climate. Objective 1, differentiate between weather and climate. This is easy. Weather is the day-to-day conditions of the Earth's atmosphere, and climate refers to the average conditions over long periods of time and is defined by the year-to-year patterns of temperature and precipitation. Climate is rarely uniform even within a region. Environmental conditions can vary over small distances, which create microclimates. For example, in the northern hemisphere, south-facing sides of trees and buildings receive more sunlight and often warmer and drier than north-facing sides. These differences can be very important to many organisms. So objective 1, sweet and simple, is differentiate between weather and climate. So a region's climate is defined by the year-to-year patterns of temperature and precipitation. Weather is daily patterns. Objective 2, identify the factors that influence climate. All right, so the main forces that shape our climate is solar energy that arrives as sunlight that strikes Earth's surface. Some of that energy is reflected back into space, and some is absorbed and converted into heat. Some of the heat also radiates back into space, and some is trapped in the biosphere. The balance between heat that stays in the biosphere and heat that is lost to space determines the Earth's average temperature. Earth's temperature is largely controlled by concentrations of 3 atmospheric gases: carbon dioxide, methane, and water vapor. These greenhouse gases function like glass in a greenhouse, allowing visible light to enter by trapping heat through a phenomenon called the greenhouse effect. If greenhouse gas concentrations rise, they trap more heat, so Earth warms. If their concentrations fall, more heat escapes and Earth cools. Without greenhouse effect, Earth would be about 30 degrees Celsius cooler than it is today, which is quite a bit colder. All right, so how does latitude and solar energy affect our climates? So near the equator, the solar energy is intense, as the sun is almost directly overhead at noon all year. That's why equatorial regions are generally so warm. The curvature of Earth causes the same amount of solar energy to spread out over a much larger area near the poles than near the equator. Earth's polar areas annually receives less intense solar energy and therefore heat from the sun. The difference in heat distribution creates different climate zones: tropical, temperate, and polar, as you can see there. The tropical zone, which includes the equator, is located between 23.5 north and 23.5 degrees south latitudes. This zone receives nearly direct sunlight all year. On either side of the tropical zone are the 2 temperate zones between 23.5 and 66.5 degrees north and south latitudes. And then beyond the temperate zones are the polar zones, between 66.5 and 90 degrees north and south latitudes. Temperate and polar zones receive very different amounts of solar energy at different times of the year because of the Earth's axis is tilted. So as the Earth revolves around the sun, solar radiation strikes different regions at angles that vary from summer to winter. During winter in the temperate and polar zones, the sun is much lower in the sky, days are shorter, and solar energy is very much less intense. Heat transport in the biosphere. The unequal distribution of heat across the globe creates wind and ocean currents, which transport heat and moisture. Earth has winds because warm air is less dense and rises, and cool air is more dense and sinks. Air that is heated by warm areas of the Earth's surface, such as near the equator, rises and expands, and spreads north and south, losing heat along the way. Then as the warm air cools, it begins to sink. In cooler regions near the poles, chilled air sinks toward the Earth's surface, pushing air at the surface outward. This air warms as it travels over the surface and rises. These upward and downward movements of air create winds. Winds transport heat from regions of rising warmer air to regions of sinking cooler air. The Earth's rotation causes winds to blow generally from west to east, over the temperate zones, and then from east to west over the tropics and the poles. Similar patterns of heating and cooling occur in the oceans. Surface water is pushed by winds. Ocean currents, like air currents, transport enormous amounts of heat. Warm surface currents add moisture and heat to air that passes over them. Cool surface currents cool air that passes over them. In this way, surface currents affect the weather and climate of nearby land masses. Deep ocean currents are caused by cold water near the poles sinking and flowing along the ocean floor. This water rises in warmer regions through a process called upwelling. Very cool stuff, isn't it? So objective 2 was identify the factors that influence climate. Global climate is shaped by many factors, including solar energy trapped in the biosphere, latitude, and transport of heat by winds and ocean currents. So that was our quick lesson for today. Can you differentiate between weather and climate? And can you identify the factors that affect climate? Oh, I did that twice for some reason. Oh, there's my picture, so I can turn off my video. Have a good day.